No-code fine-tuning of large language model is a breakthrough in the open source world. This will make fine-tuning 10x more accessible to everyone. So if you are frustrated with the complex task of setting up GPUs and multiple Python libraries and version compatibility issues for your language model fine-tuning, then let's shift gears and simplify your life. This is 2024, and fine-tuning a pre-trained large language model for your business does not need to be complicated. Enabling novice users to fine-tune complex models with little friction is absolutely remarkable and very possible. Introducing Monsterapai's no-code large language model fine-tuner portal, your gateway to hassle-free fine-tuning. Imagine launching a fine-tuning job seamlessly in just few minutes without writing any code. And also, if you have a unique custom dataset ready for fine-tuning, no problem. Monsterapi embraces diversity, welcoming any dataset you bring to the table, ready to fine-tune your model with precision. And what's next post fine-tuning? That's deployment. And here as well, they have got you covered. Transition smoothly from fine-tuning to deployment with Monster Deploy, which effortlessly converts your custom LLMs into ready-to-use API endpoints. Whether for a web or mobile application, integration is a breeze. So embrace the no-code revolution. With Monsterapi, fine-tuning is not just simplified, it's democratized, making advanced LLM personalization 10x more accessible. Dive into the future where ease meets innovation, and let Monsterapi transform your LLM fine-tuning journey today. Monsterapi supports 3 key techniques that make the platform even much better compared to many of its competitors. And these includes QLoRa with 4-bit quantization and NF4. This feature reduces the size of the model by compressing them using quantization technique. This allows users to fine-tune larger models using less memory and bandwidth. I will discuss it in slightly more detail in a second, but first just go over another 2 key points that Monsterapi has and which are of hugely importance when you are fine-tuning. So the next one is Flash Attention 2. This feature improves the speed and efficiency of training by using a novel attention mechanism that reduces the computational complexity of the models. And the third one is Data and Model Parallelism on multiple GPUs. This feature enables users to train bigger models using larger context lengths by distributing the data and the model across multiple GPUs. Alright, here is a quick snapshot of fine-tuning with Monsterapai's no-code portal versus AWS and Replicate, which is another provider. Now, for the preparation, for AWS, you need to set up the AWS account, install CLI, SDKs, and understand the billing, and sometimes it's a huge process. You really have to go through all the hassles here. And for Replicate as well, you have to sign up, review documentation, etc. And with Monster, sign up, it's a no-code approach. Very simple setup. Then compute resources, select from for AWS, you need to select from a wide range of EC2 instances based on needs. And you really need to have a little bit of idea about these EC2 instances, launching and closing them, else you can really incur a lot of cost unless you are very careful. With Replicate, it's limited by Replicate's offering less control over specific resources. It is slightly more simpler than AWS. But with Monsterapi, it's the simplest and the fastest because it's a decentralized GPU network and optimized for memory usage. And you really don't have to set up many things here at all. And with Monsterapi, there's also advantages for linking your datasets because here with Monster, you can directly link the Hugging Face datasets. And there's a drop-down indeed, where all the main and famous Hugging Face datasets are directly there. You can just select it. And if you are uploading your own custom dataset, you can just upload it directly in the portal before launching your fine-tuning job. And of course, with AWS, you have to use S3 and you need to know the S3 configuration, etc. And Replicate also is dependent on its own storage solution or external storage. And then continuing on this line, Monsterapi's development environment is much more simplified. It's very user-friendly and very easy to set up. We will see that in a minute. and it has all the predefined tasks versus AWS's SageMaker, which of course very comprehensive, but it has a lot more complexities. And then in the fine tuning, again, fine tuning is very simple. You just need to set up the configuration, which we'll see in a minute, and it supports Monsterapi supports all the latest technologies like QLoRa, flash attention 2, and parallelization of your multi GPU setup, etc. And for monitoring and optimization of your fine-tuning job, of course, SageMaker provides you lots of comprehensive tools, but your support from Monsterapi is also great. You get performance monitoring through detailed logs, optimized algorithms for better performance. So overall, I think the three most excellent points about using Monsterapi are these: ease of use, speed, and affordability. So I would say Monsterapi almost democratizes the work of fine-tuning a large language models, because by many people it's still considered very complex, needs a lot of money and great compute resources. But with Monsterapi, because everything is taken care of for you, so you can very much just launch the fine-tuning within maximum 5 to 6 minutes. That's it. So if you are a user who is seeking simplicity, affordability, and efficiency, and without a lot of hassle, then this is the go-to tool for you. All right. Now, earlier I said that Monsterapi supports QLoRa or LoRa training. Now, to the background, over the past year, LoRa, that is low-rank adaptation, has pretty much revolutionized fine-tuning, and almost every fine-tuning job in the industry is using some form of LoRa and QLoRa. So let's just quickly see why they have become so important. So the core idea behind LoRa is that original weight matrix W is adapted by adding a low-rank product of two much smaller matrices. So when fine-tuning with LoRa, the original matrix W is frozen and only the elements of the low-rank matrices are trained, leading to a drastic reduction in the trainable parameters count. And QLoRa, that is quantized LoRa, further elevates this concept by introducing quantization into the mix. The mechanism here is about reducing the precision of the elements in weight matrices. So instead of using high precision floats like 32-bit floating point numbers, quantization represents these values with lower precision formats like 16-bit or 8-bit or even 4-bit. So the reduced precision means that each number takes up less memory. For instance, a 8-bit integer uses 4 times less memory than a 32-bit float number, leading to a hugely faster calculation and a huge savings in compute resources when fine-tuning. The genius of this approach is in striking a balance between efficiency and model performance. While quantization introduces some approximation error, the impact on model accuracy is typically minor, especially when fine-tuning on specific tasks where the adaptation scope is limited. And now with Monsterapi, you can completely use QLoRa and LoRa up to as low as 4-bit quantization precision, and again without writing any single line of code, because all you have to do to integrate quantization, that is QLoRa and LoRa, is just change some configuration when setting up your fine-tuning job. All right, now we are going to do an actual fine-tuning using the Monsterapi portal. So the first thing you do is sign up, and once sign up, you will get some credit, which is enough for you to do some basic experimentation with some of the models, that is the popular ones. And right now I'm looking at these fine-tuning LLMs, these tab in their site, and it has got a lot of information. You should definitely go through them. And they have some great blogs written pretty recently with the latest information on the actual fine-tuning workflow, etc. And also do check out their pricing before you start actually hacking around, because you need to be aware that for each minute you fine-tune, there's a cost to that. So definitely go check out their pricing, which is actually very, very reasonable to my experience. Now, in this video, I'm going to do fine-tuning on Gemma-2b, the great model from Google. So before actually starting the fine-tuning, let's quickly learn about very basic information on Gemma. So Gemma is quite an outstanding model, and what most possibly contributes to Gemma's outstanding performance are that number one, the large vocabulary size that Gemma-2b has. So it has got 256,000 words. In contrast, LLaMA has a vocabulary of 32,000 words only. And also, Gemma has an extensive 6 trillion token for its training dataset, while again, in contrast, LLaMA was trained on only 1/3 of that many tokens. So something else worth noting is that Gemma-2b utilized multi-query attention, and almost closed model that Google released along with Gemma-2b was Gemma-7b, and Gemma-7b's did not use this multi-query attention. And here I also want to mention a great results that was achieved by Monsterapi with this Gemma-2b model. So Gemma-2b model was fine-tuned on Monsterapi, which outperforms LLaMA 13b on mathematics reasoning. And for the training details of this particular project, Gemma-2b underwent fine-tuning on the Microsoft Orca Math Word Problems 200K dataset, which is very popular for mathematics related dataset, for 10 epochs using Monsterapi's Monster Tuner service, the service that we are using in this video. And the performance of Gemma-2b and the standard Gemma model was evaluated on the GSM Plus benchmark, which assesses mathematical reasoning ability of language models. And the reason that this GSM benchmark was used because GSM Plus benchmark is able to rigorously test language models' proficiency in addressing grade school mathematics, providing a robust framework for evaluating their capacity for mathematical reasoning and problem solving. So this benchmark serves as a very common tool in the industry for comparing the mathematical intellect across diverse language models. Now, coming back to the evaluation result of this particular project, the Monsterapi fine-tuned Gemma-2b model achieved a remarkable score of 20.02 on GSM Plus benchmark. This represents a 68% improvement over its baseline model performance. Notably, it outperformed larger models like LLaMA 213b and CodeLLaMA 7b on this benchmark. I am in their fine-tuning portal. So this is the dashboard tab, and you can see that I have got a free credit of 2,500 here after signing up. And you just go to fine tuning and create new job. I already have a default name given. And once you create, click on this particular option here, create a new fine tuning job. You will have quite a few different class of fine tuning. You can fine tune a Whisper model, SDXL model. For now, I'm going to just choose fine tuning an LLM. So it will give you a default name, and definitely you can check it because this particular fine tuning I'm going to do on Gemma. So Gemma-2b fine tune. Okay, and in the model, again, you have the whole array of models here, all the popular ones available in Hugging Face and popular in the industry. So let's search for my desired one, which is Gemma. Yes, under Google, you will see the two versions of Gemma, 2b and 7b. For now, I'm just going to choose 2b and next step. All right, so here, this fine-tuning I'm going to do on an instruction fine-tuning base. That is, so I need to, when you choose instruction fine-tuning, that means you have to choose a compatible data set. Because the fine-tuning of an LLM may be instruction or text classification or summary generator. There's many classes of fine-tuning. So probably the most popular ones, like for example, the ChatGPT, all the popular models, they're all instruction fine-tuning. So I'm going to choose that one. And now the important part, data set. So once you click here, these options are the most popular ones, and they are actually supporting pretty much all the data set that Hugging Face has, and you can find it here. And if you don't find it here, then you just choose other. And also the most important thing, that you can bring your own data set. So you just click on data set, this particular small link here, and it will take you to a new new window, and here you can upload your own data set, and that could be a JSON file, JSON-AL, CSV, Paraquet, and zip file, or even a collection of image in case you are doing fine tuning of a computer vision model. All right, but for this one I am going to close this because I'm going to choose a dataset that's available in Hugging Face. And for that, what you do is first I am going to my Hugging Face homepage, and there I am going to search a dataset named as Alpaca GPT-4. It's a very popular dataset for instruction fine tuning, and that is the reason I am choosing it. So once you type here, it will give you all the options, and this is the one that I'm looking for, Alpaca GPT-4. Okay, just click on that. Right. So here's my dataset, and so this is a dataset format. It's an instruction and then output. This is the two main columns that I'm going to need, and we have 52,000 rows in the trend set, and this is definitely an instruction dataset. And overall size is 48.4 MB, so pretty much on the smaller side, so we can easily manage it. And remember, this input is some extra context for these datasets, so not all the rows has this input. And so the main two things that these two columns we need, this is the instruction column to the LLM, and this is the output or response column. Okay, so what I need to do here is go back to my portal, Monsterapi, and here choose other. Once you choose other, then this next box will get activated, and here you type your dataset name. So just like it says, enter a Hugging Face dataset name of your choice. So I'm just typing it here. Does it give anything? No. So let's go back and copy the entire this thing, that is the actual creator of the dataset. So I need to copy the entire sentence and then fetch dataset. Yes, success. So note here that if you just put the last part of the dataset, that is just only the name without the creator, that is without the entire string, then see what happens. I just put here and do fetch dataset, and it will tell me error. That's why you need to put the entire string of the name of the dataset and then fetch dataset, and then it will say success. Okay, I'm keeping the subset as default. Validation split also, I'm keeping it at 10%. You can definitely change it to whatever percentage you want for your use case. And then this prompt configuration, very important part, because this is an instruction fine tuning that I'm doing. So I need to have two columns specifically for instruction and then response. Now, let me check the dataset again. I have a column named instruction, so that's fine, but I do not have a column named response, but the output is what actually represents the response. So accordingly, you have to change it here. Let's quickly read what it says. Below is an instruction that describes the task. Write a response that appropriately completes the request, right? So replace with the instruction column name. So here my instruction column name is just instruction, and the response column name is output for this dataset. Okay, yeah, that's fine. And then next step. And these are all the regular parameters, or rather hyperparameters, that you probably are aware of if you have been doing fine tuning. So they pretty much represent all the parameters that Hugging Face Trainer API or any other library, for example, the Trainer API of TRL library will give you. So you can configure your training job by changing all these hyperparameters. So epochs, increase it to your requirement. Context window, again, you will have all the standard number, for example, 512, then you will have 1024, etc., etc. Early stopping, patience, learning rate, these are all very, very important and very standard hyperparameters. And then for tracking your job, you can connect it with your 1DB, that is weights and bias account, so that your entire history, your training log, etc., everything is logged properly. So you just put your username, and that is 1DB username, 1DB key, project name of 1DB. And similarly, for after the fine tuning is done, to push the model, that is a fine tuned model, to Hugging Face, you can put your Hugging Face key here, that is a authorization key from Hugging Face, and model path. and it will be saved in your Hugging Face account as a fine-tuned model, which you can directly pull from Hugging Face and of course make it public. After selecting all this configuration, you can actually set all these advanced settings. So once you click on this advanced setting portion, you will see all these extra hyperparameters, which are super important for any serious fine-tuning job. So for example, you can select your LoRa R, that is a rank parameter. By default, I think it takes 8. 8 is a minimum number. That's the default number, and you can definitely increase it. And for the explanation, these are hyperparameter represent the rank of the low rank metrics learned during the fine-tuning process. So this rank parameter basically indicates how much information is packed into the metrics. So as this value is increased, that is the value of this R parameter is increased, the number of parameters needed to be updated or trained during the fine-tuning also increases. So higher value of this param will mean training will go on for a longer period of time, and a lower value of the R parameter will lead to a quicker, less computationally intensive training process, will be done much faster, but may affect the quality of the model thus produced. So that was the rank parameter. Then dropout. This is again a very vanilla parameter, and most of the fine-tuning job, depending on your data set and depending on your target, you may want to change it. And for the learning rate scheduler, I can see it supports quite a few of the popular ones. I mean, this is all the learning scheduler you will need. Most of them are supported here. By default, it takes reduce LR on plate. Of course, you can choose linear, cosine with restarts, polynomial, constant, etc. Fantastic. And then LoRa alpha, this is another hyperparameter. 16 is the minimum number and the default number, and you can change it. And then you can also set the gradient accumulation steps right here. And gradient accumulation is a technique primarily used when the batch size required for training a model is too large to fit into the GPU memory that you have. So instead of reducing the batch size, which might affect the training dynamics, for example, model might converge to a different local minima with smaller batch sizes, gradient accumulation accumulates the gradients over multiple mini batches and updates the model's weights less frequently. So this step determines after how many steps this accumulation should occur. And so this is again a hyperparameter, and you should experiment with different value of these while fine-tuning. All right, when you click on next, this is the final step before your fine-tuning starts. And here you will see a comprehensive view of all the configuration that you have built up till now, all the hyperparameters, etc. So for example, that you can see that I'm using LoRa, so use LoRa is true, epochs 4, gradient accumulation steps 32, etc. And if anything looks incorrect for you, you can just go back and change it. And one very important thing is that this statement right here, to avoid service interruption and ensure your fine-tuning job runs to completion, when your credit balance is low, you may set up auto payments here. So you will get 2,500 free credit once you sign up, but that 2,500 may not be enough for this particular one, because see, the estimates given here is 40 to 60 credits per minute. So even if I assume 40 credits per minute of fine-tuning, then probably I will be able to do like 60 to 65 minutes of training. So that may be enough, may not be enough. So if you are unsure, you can just go and buy a plan to complete your fine-tuning. And for that, you can just go to their pricing page here. It's very well written here. All the details are very much here. So we have a Wolf plan, which is 9 USD. You get 9,000 credit under this plan, and then they have a Beast plan, 29 USD. With that, you get 35,000 credits, which is actually a lot. Up to 10,000 daily API calls, 7,000 image generation, 250 hours of audio transcription. All right, that's huge. And 750 minutes of fine-tuning. Yeah, 750 minutes is really huge. And if you want a kind of estimation, you can just go down in that page, and there's a section where you can choose different jobs. So by default, it's taking text to image. For me, I am interested in 2B fine tuning. So Phi2, this model is also a 2 billion parameter model. And so this is kind of equivalent with Gemma-2b. Of course, Gemma-2b is, I think, slightly bigger than Phi2. But let's just see. And the number of tokens to be generated per request. Let's increase it. Maybe, yeah, let's keep it 1500. Total number of requests per month. Let's keep it at maybe 100,000. Yeah, something like that. So that would that is the estimate. Under this condition, you will be charged around 46.8. It's just an estimate. All right, it may vary. So this is the pricing page, and to my opinion, it's quite a very competitive price and very reasonable price indeed, because you are getting 750 minutes of fine tuning with a good amount of GPU hours with $29. Okay, now let's proceed. So after I am satisfied with all the hyperparameters, you can just click on create job, and it will start creating the job. So now at this step, it may take a couple of minutes before the job is started, because it will launch the machine for you and do all the GPU configuration, etc. And everything is happening in the back end. You don't have to do anything. You just wait here. And in the meantime, I just want to show you something else. All right, just a quick point here. Right now, we can see that the status currently is starting, and it says that your job is getting launched. It may take 5 to 10 minutes. So at this current status of starting, no credit is being consumed. That's very important to remember, because only when the fine-tuning process actually started, then only your credit will be consumed. So not to worry at all. And you can check the details of view job info. It says 11th April 3:09 a.m. deployment ID, etc. and all these things, and all the configurations are also given here. And you can clearly see credit consumed is 0. So because it's still in the starting status. In the meantime, we'll quickly go through the documentation, because everything I just said till now about this is very well written and well organized in their official documentation. So right now I'm looking at their documentation under the guide section of Monsterapi. So they have all these different section: introduction, then fine-tuning an LLM. This is what is important for us currently. So let's see what they say. Curated list of models we support for fine-tuning. As you can see, the lots of models, and these are pretty much all the popular models currently in Hugging Face. And about the dataset preparation, they say this. You may also refer to our guide on our custom dataset for LLM fine-tuning. And maximum supported cutoff length for models. This is, they are talking about the context window. So models with less than 30 billion parameter 2048 is a max context window. This is the number of tokens, and models with more than 30B, it's 512. Remember, for our case, we just selected 512. And in the guide, one particular area I wanted to show you is this one. Use any other unlisted Hugging Face dataset, because in my case, we just use a default pre-built dataset, but they have complete flexibility here. That is, if you are unable to find a Hugging Face dataset of your choice in our curated list, then you may choose other option and provide dataset name for the Hugging Face dataset to fetch and use. Yeah. And also check out their custom dataset portion. So it enables you to upload your bespoke datasets directly to Monsterapi platform, providing a seamless way to fine-tune LLMs on your specific dataset. And also they take care of your data very well with data privacy as our utmost priority. This service ensures secure, confidential utilization of your personalized datasets. So yeah. That's very important. And also, once your job starts, that is a fine-tuning job starts, you can check the complete status and tracking. And there's a guidance on that as well. So a job can have 4 states: launching, in progress, completed, failed. When a job is in progress, after launching, it typically takes 4 to 5 minutes for the job to enter the in progress state. That is, once you keep it ready and launch it, it will take this many minutes. And during this phase, you can view job logs by selecting view logs, etc. All right. And billing. Here is what jobs are billed based on the time they are in progress, typically consuming 40 to 55 credits per minute, ensuring your account is has at least 500 credits and a valid payment method set to avoid job termination. Yep. And after waiting for a couple of minutes, I can see my fine-tuning job has started, and it's clearly showing in progress. And if you click on the job info here, you will get all the details. Credit consumed already 204, and yeah, launch time is this one. So this consumed credit is a live number. It will continue to get updated. So at any time, if you want, you can of course terminate the fine-tuning process by clicking here and then terminate. Okay. And remember, once that full fine-tuning is done, because I have already, during the setting up of my fine-tuning job, we already set up the Hugging Face Hugging Face authorization token, etc. So the fine-tuned model will be pushed to Hugging Face automatically. You don't have to do anything. And also because we gave the weights and bias API token, there also the whole log of the fine-tuning will be available. So these will all be available to you and ready-made once the whole fine-tuning is done. So that was the workflow of fine-tuning. And I also quickly wanted to show you a deployment notebook, because like I mentioned earlier, that once you have your fine-tuned model, and then you can deploy your custom LLM, that is your fine-tuned LLM, as an API endpoint. And Monsterapi will provide you a REST API endpoints, which can then be integrated into any public web or mobile application. And this collab notebook I got from Monster itself. They have actually given quite a few example notebook in their site, so you can actually visit this page projects using Monster API, and there are so many examples for various situations, and for each of them there is a collab demo. So for each one you will have the complete code for you to run and deploy and see the effect. So let's very quickly go through this collab. It's only very few lines of code for actually deploying an API endpoint using Monster API deployment service. So first, of course, you need your API key, and then you need to install these pip packages, Monster API, and then bring in your relevant module from the Monster API. So here, this particular line is just bringing in the MC client, which is coming from Monster API package, because this MC client will manage your client-side code here. And to the MC client, you pass your API key. And this code is so simple. It's just basically you are defining few configuration. That is all. And once this deploy client is defined, you need to create an LLM deployment. And remember, this whole deployment is using this LLaMA 7B model with LoRa adapter that was previously fine-tuned. And that's what it is serving, that this notebook is serving. So to create the LLM deployment, first you need to define your launch payload configuration. So that is your base model path, your LoRa model path, and then prompt template, API auth token per GPU VRAM, GPU count, etc. And then launch the deployment with this line, return deployment client, deploy client dot deploy. And then you pass your LLM and launch payload that you just defined. And that will give you a deployment ID. You can print that deployment ID. And then these are various deployment status. That is, for example, below mentioned are different types of status responses. So in progress, status pending, status failed, then building, and finally live. This is the most important one. That means everything is just live. And this status is for terminated user, because after your deployment time is over, you need to kill it by terminating the deployment. Okay, so once the deployment is live, let's query our deployed LLM endpoint. So this particular code is just for querying. So first you check with this assert line that the deployment status is live. And then service client is coming from MC client. Base URL status return dot get URL, and then here you defined your payload. Here the input variable, your Prompt goes, write a Python script that reads from CSV file and output to JSON file. Okay. And then I get the output from the model with this line, service client.generate. And then I am doing this payload.getStream for I in outputs, print I0. And this is what it outputs. Let me see the output in more detail. Yeah, this is the output I get. It's defining the method right here. Okay, now one thing I wanted to point out is at the very top when I'm defining the base model path and the LoRa model path. So here the theory is that once you have fine-tuned an LLM on Monsterapi, you will receive the adapter weights as the final output. This adapter contains your fine-tuned model's weights that Monster will host as an API endpoint using Monster Deploy. And Monster Deploy optimizes its, and that's the reason I am passing these base model path and the LoRa model path. So the LoRa model path is actually the adapter weight. This is a zip file. And Monster Deploy optimizes its backend operations using the VLLM library. VLLM currently is the most popular library for fast inferencing on a large language model, and it's especially notable for its state-of-the-art serving throughput. All right, that's a wrap for this video. Stay tuned for the upcoming ones. Thank you very much for watching, and we'll see you soon.